How you guys doing? Thanks for coming to the webinar today. Today, I've got some exciting information to share with you. We're gonna talk to you today about things you can do inside of your home to reduce energy consumption without putting solar panels on it. So, those of you that are interested in learning about how to conserve energy inside of your home, it's gonna be some great information that we share with you today. I'm gonna share a PowerPoint presentation with you as we talk, and that'll give you some basic information and things you need to do to help save you on those energy bills. Unfortunately, they're only going in one direction and it happens to be up. A little bit about us, Eco Elements. The original division of Eco Elements is actually a home inspection division. And what we noticed during those home inspections is we kept running into efficiency issues inside of homes. And homeowners would ask us, what do we do about this? What do we do about that? How do we fix that? Who do we have come and do an evaluation on our home? And how do we fix those issues? And unfortunately, what we found was there was no one out there at the time to go in and look at a house from an energy evaluation perspective. So what we did is we put some heads together and we created this division, Eco Elements. Its job is to help identify those issues inside of a home, help you save money, reduce wear and tear on your furnace, your air conditioner, your water heater, all of those appliances that consume energy. And we're gonna go over things today that can help you reduce energy without adding solar panels to your home. We actually believe in an adage by Gandhi of be the change that you wish to see in the world. Naturally, we as individuals have to do our own part. Our goal as an organization is to help conserve energy, naturally save money, and in turn help protect the environment. Naturally, Mother Earth is a very important piece of what we do as well, so naturally we need to do our part. A couple of organizations that we support are local fire and sheriff's office, police. We carry an A rating with the Better Business Bureau, as well as many 5-star reviews on Google. The Children's Justice Center of Salt Lake is an organization we support as well in helping with taking care of our youth and our future generations. What we're gonna go over today, cutting edge products that are specialized in energy conservation. What we do as an organization naturally is a white glove experience from audit to install with those homeowners that we work with, creating comfort. Now our goal today, or the things we're gonna discuss, number one, cutting heating and cooling bills substantially. Naturally that bill comes every month. Sometimes we cringe, whether it be the heating bill in the winter or the cooling bill in the summer. Number two, save wear and tear on heating and cooling equipment. Those units are very expensive to replace. So naturally, if we can extend the life of those, we're gonna be doing better as well and save us money. Eliminating hot and cold spots within your home. If you have that one room, super hot, super cold, depending on the season. Creating a healthier, more comfortable environment, helping preserve the environment, potentially increasing the resale value of your home if you do choose to sell it later, and becoming less dependent on foreign energy. Now I'm gonna stop here for a minute, because unfortunately, if you've lived in your house over 5 years, or even over the last couple of years, you've noticed that our utility rates are not going down. Unfortunately, they're only going up. Now, as we look at that, all we're doing is spending more money over time, energy, and less comfort. So we wanted to discuss that specifically and tackle it. According to the US Department of Energy and HUD, unfortunately, this is the direction we're headed in. So if you are on average right now spending $100 a month, $100 in 10 years from now is gonna be $189 a month. As you can see, you can kind of find your own bill here, 100, 150, 200, 300, and follow it down where they're saying you're projected to go in terms of that utility cost 5, 3, or even 10 years from now. So unfortunately, the only direction is one direction, and it happens to be up. Now, when we break down that bill, they say that energy goes to certain areas inside of our home. First area is 18 to 22%. That happens to be for your appliances and your lighting. The second section of that happens to be 10 to 12%. That's going toward water. We like hot showers. But the biggest chunk that we use that energy for every single month happens to be heating and cooling. 50 to 60% of that bill every single month goes towards heating and cooling. Now, first thing we're gonna talk about today in terms of energy consumption and reducing it is this little guy right here, the condensing unit inside of your central air system. There's an organization called ASHRAE. That stands for the American Society of Heating, Refrigerating, and Air Conditioning Engineers. It's kind of a long acronym, but what they've done is there's 7,500 of those engineers nationwide. They've done studies on air conditioners. Now what they found, you buy a brand new condenser and put it on your home, you're gonna lose 7% efficiency year number 1. Let's say it was 100% efficient, now it's 93% efficient. Year number 2, they say you're gonna lose an additional 5%. So you've owned it 2, you've lost 12% efficiency. Year number 3, beyond, is 2% efficiency loss, up to 30 to 40% in efficiency loss. Now you can do the math on your own unit. If it's 6 years old or 10 years old or 20 years old, do the math on your efficiency loss. But the real question is, why does that happen? The issue, according to the ASHRAE study, is an issue called oil fouling. Now inside of that system, there's 2 things. One is a lubrication, the other is a refrigerant. The compressor motor's job is to move that refrigerant through the system. But over time, just like this bottom left-hand corner photo, we get a decreased flow of that refrigerant due to the fact that the lubrication inside is actually building up on the inside of that coil line, the supply line to your furnace and the return line coming back. Now what that means is, I like to use the example of clogged arteries in a body. If I have clogged arteries in my body, what happens to my heart? It takes it longer to circulate the blood throughout my entire system, and it causes all sorts of issues: stroke, heart attack, shortness of breath, potentially death. And so those are the issues caused by cholesterol buildup. Well, unfortunately, that little unit outside that's designed to keep your house cool in the summer is running into the same exact problem. It just happens to be with the lubrication. So the question becomes, how do we address that oil fouling, or that buildup of quote-unquote cholesterol on the interior of those lines? We use a synthetic additive called Coolmax. Its job is to be cholesterol medication for your air conditioner. It breaks up the oil that's adhered to the inside of those lines, and it applies a thin layer so it can't adhere in the future. Now what that does is a few benefits. Number 1, it increases the flow as well as decreasing the wear and tear on your compressor motor. But the result that homeowners see inside of their home is it actually lowers the vent temperature blowing into your house by 6 to 9 degrees. If I'm pumping colder air into your home when that air conditioner is running, naturally the house cools off faster, the system doesn't run as long, and we save wear and tear on that unit. In turn, that means we save money. Next thing we're going to talk about today happens to be insulation. Now, it doesn't matter the version, according to the US Department of Energy: batting, blown-in, blue jean, cellulose, rock wool, spray foam, all of those different versions of insulation, according to them, unfortunately only stops radiant heat gain or loss by 10%. Now, if you were taking a quiz in school and you only got 10%, what type of grade would that be? Naturally, you would be failing. And this is what we're putting in our homes every single day. New builds, retrofits, old homes, you name it. We all use batting, blown-in, blue jean, cellulose, rock wool, spray foam, any of those different versions. They also work off of what is called an R value. Now the real question is, what does that R actually stand for? We always hear it followed by a number. R19, R38, R40, R60. What that R stands for is, it actually stands for resistance. So the depth of that insulation is the amount of heat transfer that it can resist. Now the problem that we run into is, over time, that light and fluffy stuff they blow into your attic doesn't stay light and fluffy forever. It compresses, it settles, it compacts, and when it does that, heat transfers through it fast. I like to use the example here of a rainstorm. If I walk outside in a rainstorm and I don't want to get wet, or you guys don't want to get wet, what good would it do if I handed you a quilt? Now let's play devil's advocate for a minute. So for a time being, with a quilt, no matter how thick or thin it was, it wouldn't get us wet. But over time, we'd be standing out in the rain and we'd be getting wet. Now if we were to walk outside in a rainstorm and I didn't want you to get wet, naturally I would hand you an umbrella. An umbrella is going to keep that water off of you and make sure that you don't get wet. Now we're going to talk about the umbrella here in a little bit, but I want you to keep that in mind as we talk about insulation. The problem that causes, this causes a higher cooling bill in the summer, because because that heat is radiating into your living space through your attic when that insulation becomes depleted. Traditional insulation companies, manufacturers of that, say you should be reapplying it roughly every 7 to 9 years. Unfortunately, attics tend to be a place that's out of sight, out of mind. Can't tell you how often homeowners, and it's been 20 years, it's been 40 years, it's been 50 years since they insulated that attic. That causes a higher cooling bill in the summer because the heat's coming through into your living space. In the winter, this also causes a higher heating bill. Naturally, you're trying to keep your house warm, and when you're doing that, but it's not slowing down that heat transfer out into the attic and you're losing it, naturally it's going to cause a higher heating bill. Your furnace is going to run more, it's going to have more wear and tear, it's going to wear out quicker, and in turn your bill is going to go up. The question I like to pose is, do you want to resist that heat transfer, aka that quilt in a rainstorm, or do you want to stop it like that umbrella? I would assume most of you would think that you would rather stop it rather than just slow it down. Now, as we talk about attics in particular, unfortunately, we find all random things inside of attics. On the left-hand side, this was insulation from 1956. It was actually ground up wood chips. That is a fire hazard. I do not recommend doing that. On the right-hand side here, if any of you want to take a second and guess what this is, unfortunately, it's a dryer vent. You can imagine every time turning on your dryer, pumping hot, humid air into that attic, it's going to cause growth. You're also going to get a bunch of lint in there, which is naturally an accelerant and a fire hazard. We don't recommend that either. Other random things that we find, leaks, holes. That one on the left-hand side was huge. And unfortunately, mildew and mold. Now, people tell me, TJ, we live in a desert, we don't get mold. Unfortunately, yes, we do. That attic is a very prone space to growth and those type of things. It can affect our health. It can affect the structure of our home, all sorts of things. Now, how do we get to the, how do we stop the heat transfer rather than slow it down? It was actually a product developed by the space program and NASA to protect our astronauts in space. What they found was if they used traditional insulation, batting, blown-in blue jean, cellulose, rock wool, all those different versions like we talked about, if they used that and it only stopped 10% of that heat transfer, unfortunately, what would happen to our astronauts if they would have either fried and froze or froze and then fried? Now, what I'm going to show you is a video from the History Channel. Some of you are familiar with the History Channel, that talks about how they protected those astronauts in space. Now, there's two questions that we're going to pose at the end of this video. Number one, what was the solution they came up with? And number two, what did it do? So I want you to pay attention to this video real quick.
Insulation is helping us go places we could never go before, including extreme environments. When designing insulation for the International Space Station, scientists were confronted with a set of problems found nowhere on Earth.
We don't have the benefit of Earth's atmosphere when we're in orbit. And not having that benefit, we're exposed to much more extreme environments. In the same orbit, we can see temperatures in excess of 250 degrees Fahrenheit while we're in the sun, while a few minutes later be exposed to conditions that produce environments less than minus 250 degrees Fahrenheit. And we go through this 16 times a day, every day, 365 days a year.
Scientists had to rethink the entire insulation process when designing the station. The vacuum of space allows only for radiant heat transfer, usually in the form of energy waves emanating from the sun. Earth's atmosphere prevents it from being overheated by these waves. But the space station, without such protection, is subject to the extreme temperatures brought on by solar radiation. The scientists had to come up with an insulation that would safeguard it. Their solution was a multi-layer insulation, or MLI.
MLI serves two purposes. The first is to reject or reflect a lot of the sun's energy, and the second is to entrap heat that's generated internally. And by doing this, we can moderate the extremes that we see on orbit.
One of the key components of the insulation is the plastic.
On that plastic, we apply thin layers of aluminum, and that aluminum is very reflective.
The mylar is protected by an outer layer of fiberglass fabric. This layer strengthens the insulation blanket. The inner side is aluminized to prevent harmful radiation like ultraviolet light, all the layers are sewn together to create a pillow-like blanket just 1/4 of an inch thick. When designing the insulation, scientists also had to make sure it didn't weigh too much.
We use very thin layers to make up multi-layer insulation. And the reason mainly is because of weight. The pressure shell of the module itself is about 1/4 inch thick on some of these modules, and that aluminum can be very heavy. Well, the last thing you want to do is add more weight to the space station.
Working in tandem with thermal controls inside the station, this advanced insulation helps to maintain a stable onboard environment. With a temperature of 65 to 80 degrees Fahrenheit and humidity in the range of 25 to 70%. This is the future of insulation.
So as you watch that video, the first question that I posed was, what was their solution? Their solution was a product called multi-layer insulation. The second question that I posed to you is, what does it accomplish? And the thing that it accomplishes is it keeps whatever's outside out and whatever's inside in. So as we look at that scenario, multi-layer insulation's job is to stop radiant heat from entering your home, and number two, stop radiant heat from leaving your home. AKA in the summer, we don't want it coming in, and in the winter, we don't want it leaving. Now as we look at that, multi-layer is made out of 5 layers. 2 layers, top and bottom, are made out of 99% aluminum alloy. The reason we use aluminum is because in science we found that 99.9% aluminum stops 97% of radiant heat transfer. This is the umbrella in that analogy that I gave you earlier, the quilt versus the umbrella. Now when we use 99% aluminum, as we stop that heat transfer, whatever's inside your house stays in, whatever's outside your house stays out. It's also the last time you would ever have to insulate your house ever again. So as we look at that, with blown in, we're supposed to do it roughly every 7 to 9 years, over and over and over again. I consider that of insanity. Obviously, the definition of insanity is trying the same thing over and over, expecting a different result. Well, when we use multi-layer, we stop that heat transfer once and we're done. It's the last time you ever have to insulate your house ever again. Now the core inside of here, this little yellow core on the right-hand side, you see the black core that's actually in black. Its job is to use a wicking material and be an insulating core as well. Its job is to make sure that those 2 layers are separated so that the top layer can be hot and the bottom layer can be cold, or vice versa. The top layer can be cold and the bottom layer can be warm. Now, as we continue on, it also passes what is called a 5-room corner wall fire test. Scientifically speaking, what that means is they take a layer of this, they put it in a wall, corner of a wall, they light a fire at the base of that wall. If it takes longer for them hour for that product to actually catch fire and burn, it passes that test. So it also acts as a fire retardant inside of your ceiling as well to slow down any fires that you may have inside of your home. Now the core that's inside of there, that little black tiny core that's probably only about 1/4 of an inch thick, according to the John Manville Technical Center, has the R value of an average combined R value of an R15. In layman's terms, what that means is that's the equivalent of 4 inches of traditional blown-in insulation, even though it's only roughly 1/4 of an inch thick. But we don't necessarily care too much about that quilt analogy or the quilt part of it. We care about the emissivity value or its reflective capability, which is naturally 97%. So if you took a quiz in school and before you got 10% on it, you clearly failed, but then you take the same quiz and you get 97% on it, naturally that's A. So we take your attic from an F to an A when it comes to that. As we can see here, this is what happens in summer. Obviously, radiant heat radiates your attic, creating that superheated air, and then it tries to permeate into your living space. Multi-layer's job, as you can see, is going to stop it up to 97%, making your home more comfortable, reducing your energy costs, and in turn, saving you money. In the wintertime, what we look at is we want to keep the warm air in and the cold air out. Multi-layer is going to retain that heat by 75%, keeping that heat in your home, reducing the runtime of your furnace, and keeping your home more comfortable. Naturally reducing those costs, and in turn, once again, saving you money. Now, as we look at other things that we need to do and before and after photos with multi-layer insulation, as we look at Before and after photos of multi-layer insulation. In the summertime, stopping it from 97% in terms of gaining and 75% retention in the winter from leaving. So you can see on the bottom left-hand corner, here's some blown-in insulation. Multi-layer has been applied to it. Once again, some before and afters of a home in terms of blown-in insulation and then multi-layer being put over the top of it. It also ends up making the attic look fairly clean. As you can see here, it almost turns into a giant mirror. I like to call it wall-to-wall aluminum carpet inside of your attic. Now what this means for you as a homeowner. Number one, cutting those heating and cooling bills immediately, saving you money on those utilities. Number two, save wear and tear on that equipment. If we can reduce the runtime, naturally they'll last longer. Number three, help eliminate those hot and cold spots in your home. Naturally, we want those temperatures to be balanced, and multi-layer does that. Create a comfortable, more comfortable environment, help preserve the environment, increase the resale value of your home, decrease our dependence on that foreign energy, and last but not least, improve the overall comfort of your home. Now, the last thing we're going to talk about after these reviews is attic ventilation. But Energy Star, adding additional to traditional insulation, multi-layer reflective insulation saves energy both in the summer and winter by redirecting radiant heat in your home. Multi-layer insulation can help your home become Energy Star approved as well, adding value. Texas A&M also did an independent study on this. They said adding reflective insulation to an R19 proved more effective than upgrading that insulation to an R30. They also mentioned that adding reflective insulation showed a faster payback than doing traditional insulation. Naturally, either way there's a cost there, but you're going to get a faster payback when you use a product like multi-layer insulation. Now, some cases we can't use multi-layer. Good example of this is the upper right-hand corner, the vaulted ceiling, what we call a smash vault, which means there's no attic behind it, or a modular home. Say, for example, a pre-manufactured home, those type of things. Now, in those scenarios, we can't use multi-layer, even though it's fairly thin. In those cases, we actually utilize more of NASA technology, and we mimic the bottom of the space shuttle. The bottom of the space shuttle is actually made out of a ceramic tile. Now, the reason it's ceramic is because ceramic in its purest form carries a very high reflectivity to heat transfer. So that is a thermal coating that actually goes on the interior of those surfaces in terms of those vaulted ceilings or those walls, and it retains that heat or that cool just like the multi-layer does. Now what this means for you as well as a homeowner is the goal is to reduce your energy consumption anywhere from 20 to 40%. Obviously we can't guarantee those numbers, but in reality we've seen numbers higher than 40%, but typically 20 is our basement when it comes to that. So conserving energy and naturally saving money in the environment. Last thing we need to talk about today is our attics of ventilation. Unfortunately, when it comes to attics, they tend to be an area that's out of sight, out of mind, like I mentioned earlier. As we look at that, the U.S. Department of Air, the EPA says the #1 health threat is indoor air quality. That's not the air we're breathing outside. It's not the inversion we get in the valley. It's the air inside of your house. They also say between 20 and 50% of the air you're currently breathing inside of your home is coming from your attic. Now, if you've ever been up in your attic, you don't wear a respirator, you know that that's not where you want to be breathing, that is good for you. But the real question is happening. Well, if you look at your ceiling right above you, you're going to see some cuts in that sheetrock. When you see those cuts, there's typically a gap around that and the decorative housing or the decor that's there. And every time you open a door in science, there's a property called effect. The Venturi effect means we created an active vacuum in that space. We have to fill that void with air from somewhere. Holes cut in my can lights or fans or heat registers now suck some of that air into our living space. Now, if we ventilate the attic properly, we're not going to get mildew and growth. We're not going to get shortened lifespan of shingles, splitting or warping of cross members or support. There's a real need to ventilate the attic properly. The way that we recommend doing that is to take the attic ventilation from passive to active. Now, the way that we do that in this scenario is an attic ventilation system that happens to be solar powered. When we look at utilizing the sun's rays, it's free to operate. So we're not going to add to the bill, we're going to decrease it. But our goal is to keep heat, keep moisture build up out in the winter. We don't want condensation or any winter. As we look at that, the reason we also power is if I use an AC motor and an old fan, the type that we used to use in attics, those are brush motors. Their job is not to handle the type of heat that comes in an attic. An attic can be upwards of 160 degrees in the summer. That causes a lot of damage. That motor is also not designed to be in that heat. When we use a DC motor, it can handle that heat because it's a brushless motor. It also runs directly off the solar panel. It recycles the air in that attic 30 to 40 times a day, and its job is to reduce the heat in the summer. Keep that heat out of your attic in the summer. Number one, it's not going to reduce your living space. Number two, it's not going to shorten the lifespan of your shingles, because if we superheat that attic, we're cooking those shingles from inside and out. And number three is if wood gets too dry, it starts to cause splitting, warping, and cracking. We want to make sure we protect the structure. Now, this particular option happens to be solar powered. It carries a warranty. It's rated to last 35 to 55 years. It's made out of aircraft grade spun aluminum. It is literally the last fan you would ever have to put on your house. And its job is to make sure that it works every single day, day in and day out. Now, a couple of before and afters. This is a house up in Logan, Utah. As you can see how particulates are floating in that air, how kind of foggy or cloudy it looks in that picture. This is after the ventilation system has been installed. So multi-layer on the floor. As you can see the clarity in that photo in comparison. A couple of homeowners that we've worked with, this is what they've mentioned.
Hi, I'm Phil Vallis,
And I'm Cheryl Vallis.
and we have the insulation blanket in our home. We've had it probably going on close to 10 years, and we have noticed a significant drop in both our heating and our air conditioning bills, almost cut in half, as a matter of fact. And from the time we purchased it until this present date, this interview, we've probably recouped our money that we spent placing the blanket in our attic, wouldn't you think?
Yes, I think so. They've
Yeah.
been almost cut in half.
So
Our air conditioner runs less. The attic fans run less.
the
Our
heat-
rooms stay nice and warm in the winter. We used to
Right.
have drafty rooms, but not anymore.
And the big joke at our house is every other house we go to has a few can lights. We have 50 in our house. So you can imagine the leakage problem there. With the attic blanket covering everything up in the attic, we've cut off that escape route for our heating and our air conditioning. And the heat comes on not at a normal rate like it used to, or an abnormal rate like it used to. It comes on now once, twice, maybe 3 times a day. That's it. And I'll tell you what, it's worth the money. It's a good value.
It's nice and neat.
It's nice and neat. There's no maintenance to deal with, folks.
Even the attic next to the attic that doesn't have any insulation is nice and warm in the winter. It's not cold at all.
Right. So I mean, it's worth a look into. If you don't look into it, then you don't want to save money. And I think that probably puts it all together in a nutshell.
I think so.
But what I want to do now is kind of go over with you what we do as an organization. Due to the fact that you've attended this webinar, as an organization, go out and energy evaluation on your home. What that means is we're looking at windows, doors, furnace, AC, water heater, appliance, lighting, the attic, the whole kit and caboodle. We want to make sure that we look at all those things. Now, what that means is at the end of that, you're going to get a report card. That report card is going to have good grades on it. That report card may have bad grades on it if you're failing when it comes to energy efficiency. Now, due to the fact that you've attended this webinar, we've actually allocated to do an energy analysis on your home at no cost. Normally that we charge $250 for that, but because you've attended this webinar and you've been educated and you've learned about things you can do to make your home more energy efficient, we're willing to extend at no additional charge. There's going to be a link below once the webinar ends that you can click on, and you can submit your information. And what we'll do is we'll have our office give you a call, go over some scheduling questions, and find a good time that works best for you or you and your spouse to go over those findings with you. There's no obligation to purchase anything. We're literally giving you that information to see what you need to do to improve the efficiency on your home. And at that point, from there. Thank you for attending today. If you have any questions, you can reach us via email. You can reach us via the link below, and we'll talk to you then.